Hi everyone, welcome to my channel. Myself Vignesh Anand. So in this video we are going to see the basic testings of a transformer. These are the common testings which are carried out in a substation or a generating station. So in this today we are going to see about the insulation resistance test. Um, the insulation resistance test is used to check the insulation capacity of the winding of a transformer, which means the space between the winding of our transformer and with the tank, which means the tank is connected with the ground. So the insulating capacity of our winding and tank should be cleared by a insulation resistance test, because if any abnormalities or if any uh, winding or anything touching with our ground part, means automatically the transformer will ultimately goes to failure level. So always need to have a clearance between the transformer winding and with the tank. So in order to ensure the clearance, we are doing this insulation resistances. And also it is carried between the winding of the transformers. If a transformer is a three-phase transformer, means the between the phase to phase, we will do that insulation resistance test to in order to check with the capacity of our insulation level. And also this insulation resistance is a temperature dependent, which means if the temperature rises, automatically our value will get rises. If the temperature is not at a good level, if it is in a foggy or weather condition is worst, automatically our insulation resistance level also will be worst. So this is the formula for our calculating of insulation resistance tests. So for a single phase transformer, IR value should be uh, C into E divided by root of kVA. Here the kVA is the transformer serial nameplate itself. We can able to see the kVA rating of our transformer. So the transformer is mentioned in a kVA only. So that value will be given in here. Then C means for C is a 1.5 for our oil filled transformer, and also 30 for our without oil or dry type transformer. So E is our voltage, which means how many kV we are going to give, which means the primary winding voltage level or primary rated voltage of our transformer. Then three phase, for a three phase, same C into E divided by root of kVA. Here the voltage is phase to neutral. Then for a three phase delta transformer, C into E divided by root of kVA. Here the voltage is phase to phase voltage. So uh, in order to check the how much voltage we need to inject for our transformer, these formulas are being used. Then injected DC for 500 volt, here the insulation resistance is test is carried by injecting a DC voltage by using of a megger or any other instruments. So after injecting the DC for 500 volt, we should get an acceptable value of more than 100 megohm. Yeah, if the value is more than 100 megohm, which means the resistance is more than 100 megohm, means automatically your transformer is okay. Even if it will goes to giga ohms, also been great, which means the level of insulation is very much great, good. Then for 1 kV it should be greater than 500 megohm. Then for 2.5 kV it should be greater than 1 giga ohm. Then for 5 kV it should be greater than 1 giga ohm. For maximum maximum we will inject up to 5 kV only, maximum of DC voltage injection. Even it may be the transformer may be as 800 kV transformer, the maximum we will inject up to 5 kV only for clearance checking. Then Connection types for a auto transformer: HV plus intermediate voltage to earth. This is the one type of connection, which means the HV and the intermediate voltage on one lead, it will connect the measure instrument which using for DC voltage injection will connect one lead with HV plus IV, and another lead will be connected to the earth, then HV plus IV to LV, then LV to earth. This is your auto transformer connection checking for insulation testings. Then for three-phase winding transformer, HV plus IV to LV. This is one type of connection, which means the HV and IV will be connected with one lead, and the LV will be connected to another lead. Then HV plus LV to IV. This is another type of connection. Then HV plus IV plus LV to earth. Then for single phase transformer, HV to earth, LV to earth, HV to LV. Then for a shunt reactor, HV to earth. So these are all the connection leads which is need to be connected before injecting the DC voltage from the megger or any other kits. So this is your dielectric absorption coefficient index, which means DAI. We will call it as a DAI. The dielectric strength is carried by injecting the DC voltage for 1 minute, in which 15 seconds of value will be noted and 1 minute value will be noted. After that 1 minute value by 15 seconds, in which what we get, that is our DAI value. The DAI value should be as per our standard, it should be more than 1 or 1.5, like that they will mention it. So in order to check that DAI value, we are going to test by injecting the DC voltage for 1 minute, in which we note 15-second value and 60-second value, which means 15-second value and 1 minute value. So it is a time resistance test in which the ratio of leakage current consuming constant voltage. Here the voltage is constant, in which for 1 minute we are injecting. In that time the leakage current will be noted. So in order in this we can easily able to understand that R is equal to V by I. If the I value is varying, automatically our resistance value will vary, so that voltage as per that current losses or current leakage, the resistance we get will be noted. Next, polarization index. Same wise, in this we are going to inject the DC voltage for 10 minutes. So it is tested by 10-minute value by 1 minute value. So for after injecting for 10 minutes, the within 1 or 2 minutes the value will be get in a constant level, which means the impurities inside the material will get automatically reduced by the injecting voltage. So after that the value will be noted, and also the PA value should be more than 1 or 1.5, like that they will mentioned in the factory itself. So in order to check that factory value, we need to do this testing and confirm that the healthiness of our transformer, which means the clearance would be in the earth level and our insulation level is okay, like that we will confirm it. Then the characteristics of our insulation are such that the current is not a constant and it varies with time. Same wise, the as per Ohm's law, VE is equal to IR. Here the R, the I value is not a constant, so it will be varies as per the time. So this the for main purpose we are using to know about that the constant current should the constant voltage which is injecting our injected voltage. If we inject 5 kV, that's the constant voltage. Then the current is not a constant, it is varying with the time. So this varies due to this 4 kind of losses, which is this 4 kind of current will be there in the injecting current, which means the capacitive current, conduction current, surface leakage current, then polarization current. Here the capacitive current means the insulation behaves as a capacitor in a DC voltage. So the insulation between the insulation between the winding and our tank, the insulation level between the winding and the tank, in which the insulator act as a capacitor between the after the conduction of our current. So next, the conduction current is the current flowing in our conductor. Then surface leakage means the air molecules in which the due to the magnetic flux automatically it will be get conduction because because of that flux there is some conductive force in the air molecules. That is our surface leakage current. Then polarization current is the presence of a moisture level or water molecules on the conductor on the surface of the which means the outer body or inside the conductor. That is your polarization current. So the total current is the this four current will be adding with the total current, in which after analyzing after 1 minute automatically the capacitive current will be reduced to 0. So we will get only 3 of the current after 1 minute. Then after 10 minutes the polarization index current also will be get 0. So we will get only the main current of conduction current and also the leakage surface leakage, which means the air molecules leakage current only. So after 10 minutes we will get these two current only. So the automatically we will get a most probably we will get a constant current and constant value of the PI. So as I have earlier informed, this is your PI value. If the PI value is less than 1 gigaohm, then is it a hazard? The transformer is considered to be hazardous because it will be get blasted if we inject the voltage or anything. Then if it is in 1 to 1.5 gigaohm means it's bad. Mostly in the HVDC stations or in ICT, this 1 to 1.5 gigaohm level itself okay, the customers can say okay. Even if it is a bad condition also, you will say okay, because in most of the higher rated transformers this clearance will be very less, 1 to 1.5 only. So they will accept it as a okay only in a physically I am saying. Then 1.5 to 2 gigaohm is a doubtful one. Then 2 to 3 gigaohm is a adaptive. Then 3.5 to 4 gigaohm is good. Then greater than 4 gigaohm it's a excellent one. So for example, I'm saying that if we need to inject a voltage on our core clamp and core lamination of our transformer to ensure that the healthiness of the transformer, because the transformer while at the time of transit, which means at the time of travel, it may get damaged anything or internal shorting or open circuits of our windings, in which it will get into touch or in contact with our tank level. So in order to ensure that, we are going to test our inject our DC voltage on our CL to with reference of earth. So in this we are going to inject with the first one lead with the CC of our transformer and another lead of our DC voltage injection kit with the earth. We are going to inject a 1 kV in which we should get more than 500 megohm. Then CL point of our transformer, then earth with another lead of our DC equipment, which means the mega equipment will be connected. We are going to inject 1 kV in which we need to get a greater than 500 megohm. Then CC to CL, between the CC to CL it should be open condition, so in which we are going to inject a 1 kV and we will get a greater than 500 megohm. So these are all the basic things of our insulation resistance test. Okay friends, next video will be uploaded regarding with the next testing of our transformer. So this is the common things which will be seen while at the time of injecting the uh, DC voltage for checking the insulation resistance of our transformer. So see you soon, and please watch my videos and share your knowledge and gain in your knowledge. Thank you everyone. Nandri, vanakkam.